Hi all, we will solve the problem number 40 from the Civil Engineering Set 1 paper of GATE 2022, which is of 2 marks. So first we will read the question first. The correct match between the physical states of the soils given in the group 1 and the governing conditions given in the group 2 is. So we have to match group 1 and to the group 2. So we'll read out all the group 1 options like normally consolidated soil, quick clay, sand in critical state, clay of high plasticity. Now what are the group 2 things? Sensitivity greater than 16 generally related to the clays, dilation angle is 0 generally related to the sands. I'm just giving information, overall information about these words. Liquid limit can be for any soils. Over consolidation ratio can also be for any kind of soils. First we will know what are the background theory of these group 1 options. First we'll discuss one by one. Normally consolidated soil. Okay, we'll discuss what is normally consolidated soil. Consolidated soil. So generally the definition of normally consolidated soil is the current overburden stress of the soil is the maximum stress that soil ever been subjected to. So that means the maximum stress or load which is there in current situation is the maximum. Now we will also know what is over consolidated soil. It is connected to over consolidated, means the theory of over consolidated soil is also connected to the normally consolidated soil. Here the current overburden pressure, stress or pressure is less than the pressure which it has been subjected to. In the past. So here we'll go back to the first we'll discuss. So what is over consolidation ratio? The formula or the definition for the over consolidation ratio is the maximum stress soil has been subjected to, okay, divided by the current overburden stress. Okay, according to this, for normally consolidated soil can be called as NC soil, over consolidation can be called as OC soil. So now according to the definition of OCR, the maximum stress of the soil has been subjected to the current, both are equal according to the definition of normally consolidated soil. So it will be 1. For OCR of the OC soil, the maximum current stress of the soil is less than the pressure which it has been subjected to in the past. That means the denominator is less than the numerator. So definitely it is greater than 1. So this is the background theory of normally consolidated and over consolidated soil. So let's see. Here sensitivity is not related to the normally consolidated soil. Here over consolidation ratio OCR is given as 1. So now for the time being we can connect 1S, right? And let us see, we'll discuss about the quickly later. Okay, first we'll discuss about the sand in critical state. Now sand in critical state. Here if you see the question, here dilation sensitivities cannot be related to this, and dilation angle we will discuss, because dilation angle is related to the sands. Okay, we can discuss about that. So sands in critical state. So if you take dense soil, if this is the positive volumetric, negative volumetric strain, so in the initial stage the volumetric strain is 0. For dense soil, when you apply load, when you shear it, then when you shear it, the volume of the dense soil will increase, then it reaches a constant volume. There will not be any volume change, it will reach a constant volume. In low dense or loose sands, the volume will decrease when you apply shearing. So here for the dense sand, the increase in volume, this is third problem. Okay, increase in volume is called dilation. The dilation is measured in terms of angle. So at critical state means when there is no volume change, that state is called critical state. This is critical state. Okay, critical state. At that point, if you take a angle of the curve, that is 0. So dilation angle at critical state is 0. So according to this, we can relate third one to the Q. Dilation angle is 0, 3 as Q. Now clay of high plasticity. Here there are and this is one, and then we'll discuss about, first we'll discuss about the quick clay then. So quick clay, what are quick clays? Quick clays can be categorized based on the sensitivity of the clay. So what is sensitivity? First we need to know what is sensitivity. Sensitivity of clay, if you talk about, it is the ratio of intact strength to the remolded strength of the clay. Remolded strength of the clay. So what is intact strength? When there is soil which is undisturbed, that undisturbed soil strength or clay strength is called as intact strength. What is remolded? Remolded strength. When soil is subjected to, when soil is getting disturbed, when the clay is getting disturbed, and the strength, it will lose the strength. So at one point the strength will be constant after decreasing. So after that, though the soil is getting disturbed beyond, the strength will not decrease beyond. The final strength, the lower strength, when the soil is getting disturbed, is called as remolded strength. So the ratio between the intact strength and the remolded strength is called as sensitivity of the clay. So definitely intact strength will be more. So sensitivity is always greater than equal to 1. Now according to the range of values of sensitivity, here soil is classified according to the Indian Soil Classification System. Okay, IS, Indian Standard Soil Classification. So here we can see the quick clays, when the sensitivity is greater than 16, those are called as quick clays, and remaining things are given. So when it is subjected to the when it is disturbed, still the intact strength will be equal to the remolded strength, then it is not sensitive to the disturbance. That is why when it is 1, it is called insensitive. So there are different structures you can read in any standard book. So that is how the quick clays can be related to the sensitivity range. Here the sensitivity quickness can be related to the sensitivity greater than, what is that, 2 to P. Then what is left, clay of high plasticity. We'll discuss now. This one is second and fourth. So there are as it is mentioned, clay of high plasticity. There will be another kind is low plasticity clay and medium plasticity or intermediate medium plasticity clay and high plasticity clay. So generally low plasticity clays have liquid limit less than 35%, and medium plasticity clays, those liquid limit of those clays will be in between 35% and 50%, and high plasticity clays have liquid limit greater than 50%. So here there is a chart. IP is what? Plasticity index. Whose plasticity index is more, that is called, that has more plasticity. Anyway, and x-axis is liquid limit. There is a chart which shows the relation between IP and there is 20 and 35, 50, 35, 50. So these are called low plasticity clays, medium plasticity clays, high plasticity clays. That's how now this clay of high plasticity can be related to the liquid limit greater than 50. Then 4 is R. Now we'll rearrange. 2 is here anyway. So that means 1, 2, 3, 4 S, P, Q, R. S, P, Q, R. Yeah, then the answer is A. Thank you.